Hi, welcome back to my channel. My name is Radek Smulski. I'm a senior data scientist at NVIDIA, and today I would like to show you how you can get straight into any new library, any new repository that you come across. And this can be a larger repository like Pandas or Scikit-learn, or maybe a smaller one that you found on GitHub and want to get started, want to start using for your own work. So whenever I encounter a new piece of code, I try to read it, but this doesn't work that well for me. The abstractions build on top of one another, and I very quickly lose track of what is happening. So for me, this is the only method that really works, that allows me to get into more complicated code bases. It's also great for troubleshooting issues that come up when using various libraries. I started to learn to code when I was turning 30, and this means that it might be different for other people. I've gotten to know some developers who are very good and have a greater capacity for keeping abstractions in their mind and understanding how various pieces of the code base fit together, but that is not the case for me. So let me show you what we can do instead, how we can use the power of Python debugger and Jupyter Notebook to play around with the code base, to jump into the heart of the library and understand exactly what it's doing and how. And then once I've seen an abstraction in action, once I can inspect the methods that it has, the attributes that it has, from then very quickly I build an understanding and I can navigate the new code base fairly efficiently and hold my ground, even in the context of much more experienced programmers. So let me show you how that's done. Let's get started. Okay, so we will be using Jupyter Notebook, which is already a nice way to be able to inspect the various objects that we'll be working with. But in order to use the debugger, let's first install LangChain in this very specific way. So I downloaded LangChain, I cloned LangChain of GitHub, and now I need to install it on my local computer. So I'll go pip install -e dot. This will perform a pip editable install, and what this means is that when anything on my computer will import that library, it will be using the code from inside this directory that we find ourselves in. So if I make any changes to the files in this directory, it will be reflected in whatever our Python script will load. Okay, with that installed, let's jump back to Jupyter Notebook. So here I'll be doing another trick, which is the first cell here contains these special instructions, and what they tell Jupyter Notebook is that, hey, the libraries that we'll be loading, they might be edited while we're working in Jupyter Notebook. So that means that if I change the code here in this repository, I won't have to restart the kernel. The kernel will automatically reload the library to reflect the changes. So let's see how that will work. Okay, so I'm executing the first cell, and here in the next cell I'm just importing a bunch of things that we'll be using. So we want to use the chat OpenAI model and specifically use the GPT 3.5 Turbo, which is very reasonably priced. So it's quite affordable to develop against, and it also offers great performance. And then we want to use the tools that we will pass over to our language model for it to use. And last but not least, we will be initializing the agent. All right, so I would like to learn what the agent does. Let's see here. So let's load everything up, and let's see what we can do here. Let's ask the agent, what can it tell us about Mars's moons? Okay, so you see it is doing something. It is entering new agent executor chain, and we see that it outputs a bunch of text, but you know, it's a little bit hard to figure out what all of this means just from looking at it. And okay, so it gives me an answer. Mars has 2 irregularly shaped moons, etc., etc. Okay, this so our language model performed a Google search, and it returned us this answer. Right, but I would really like to understand how the library communicates with the OpenAI API endpoint, what it sends to the model, what it returns, how it all works. So let me see here. Let's see what the agent is, so that we have a starting point. Okay, so the agent is actually an agent executor that lives in langchain.agents.agent. So let's jump back to our repository and take a look at the code. So one other thing I'll do is I'll use syntax to generate exuberant syntax, which will help me navigate the code, but this is absolutely not necessary. We could have just gone to LangChain agent and find the agent executor there. But okay, so I'm here, and now I can just agent executor. So I'm looking up the tag. Okay, and you know, I've read through this code previously, so I know that most of these things, like the chain, maybe even prompt or other classes, they have a run method. They have a run method where most of the magic happens. It doesn't seem that we have a run method. Wait a second. So to execute the chain, we called run on the agent, but is there no run method defined on the agent executor? Let's take another look. Yeah, it seems that agent executor doesn't really have a run method defined on it, so I have to keep looking. Maybe the object that the class that it inherits from, maybe this has the run method defined that our code is using. And yeah, it seems to be the case. So, all right. So here's what I would like to do. I would like to somehow find myself inside the repository, inside the code in the library, while this is being executed. So I would like to be able to step through the code, step through each action, and look around what's happening. This will give me a better idea of how our agent communicates with the OpenAI API endpoint, which is what I would like to learn more about. And I would also like to learn about the various abstractions that are used in the LangChain repository. Okay, so how do we do this? Well, we find ourselves in the code. We know that this method will be called, and I can just import the Python debugger, and even on the same line I can go pdb set trace. I'm saving the file now, and let's see what happens. So as you can see, I'm not reloading anything in the notebook, and hopefully this will pick up on the changes that we've made. Beautiful. And I'm transported directly into where I set the trace, and I can look around. So this is the Python debugger. If you'd like to see the commands that are available, you just press H and enter. Okay, so these are the other commands, but I know that I only use a couple of them on a regular basis. So the LL is quite interesting because it lists the code at least a little bit more code than just a single L would, and it shows me that, all right, this is where I find myself at. Beautiful. So let's see what got passed into the run method. And if I were to just type args here, it would actually return the args that is a command of the Python debugger. So I don't want that. Let's see what will happen. Okay, so these are probably all the variables, or a bunch of variables that are defined at that point that Python debugger is able to pick up on. But what I really want to see is the args that got passed to that method. So if you put p in front of whatever you want to look at, in this case args, it will not run the command here, but it will rather print the args variable that is defined at that point. So I know that this sounds a little bit complex, but args executes a command of the debugger, and p-args will show me what's assigned to the args variable at this point. Okay, so this is our prompt. That's a starting point, and let's take a look at the code again. Right, where are we? Okay, let's do double L. This will print the entire context. Okay, so there are some output keys that exist on the object, on the instance of the object that we find ourselves inside. We can look at them, of course. Why not? Okay, so the output keys are output. I wonder what self is. That is interesting. What is self? So self, right, that's the agent executor. And now I can just keep stepping through the code and learning as I go along, encountering various objects and various bits of functionality. So to proceed further, I press N. There we go. And it takes us to the next line of code. Well, not necessarily the next line, because we were somewhere here, but essentially to the next statement that will be executed here. So right, so this was evaluated, and since this condition is false, it didn't step into that if block. Rather than doing so, it jumped to the next if block. All right, so this is something that's looking at quarks and args, not very interesting, possibly, but I have a sneaky suspicion that this will evaluate to true. So let's see if this is what will happen. Yeah, I would have to again do the p. Yeah, that is true. So if I now do N, which is an abbreviation for next, what happened? Right, it continued the execution of our code, and we find ourselves here. All right, well, args, right, so it checks for the args being of some specific length. It needs to contain exactly a single value. We don't care too much about that. This doesn't seem to be that interesting. We want to see how our program, how the agent executor communicates with the OpenAI API. So let's keep going. Okay, this is something interesting. So it seems that self, which is the instance of agent executor that we find ourselves inside, it will call the dunder call method and pass the output keys. Right, this seems a little bit tricky and complex, so I can at this point, where were we? We need to go to our agent executor and look at the call method. I wonder if it's defined here. No, it's not defined here. Again, interesting. So we have to go to chain, and the call method is right here. Right, so we could read through that, but again, there's a lot going on here. It will be much better to step into that method and see what happens. So I'm pressing S, and I'm telling PDB to take us inside that method call. Let's see if it will work. Yeah, it seems to have worked. So we now find ourselves in LangChain chains base. Right, so this is where we thought that the functionality will run, right? Where the call method is defined, and let's see what we have here. Okay, right. Well, let's continue stepping through the code. Let's see what happens next. Okay, so what were our inputs to this method? Let's take a look. So the input here is just the prompt that we passed to the agent executor, and we see that they're getting prepared somehow. They're getting prepped somehow. All right, let's see what happens here. Now you see this line of code executed, and we were taking to the next line of code. So let's see what our inputs variable holds now. Okay, so it just slightly reformats the inputs into a dict, and now the callback manager. So a callback gets triggered. I'm not entirely sure if this is something that is very important. No, that maybe is something that I'm guessing I might read through the definition of what's going on here to understand the situation better. But in the interest of time and the tempo of this video, let's just keep on moving. I'm assuming that just based on the name that this is just some callback mechanism that allows you to run arbitrary code at various points of the chain. So let's continue. Let's continue. Right, we're executing line by line here. Nothing too exciting. Okay. Right. And now, okay, so it printed this entering new agent executor chain. Okay, but this doesn't seem like it has done much. And now we see that the method that we find ourselves in, that it wants to run the underscore call method and pass inputs to it. So that immediately suggests that this might be something interesting going on here. Maybe that's where the gist of the functionality lives. So let's step into that function. Again, I'm using as. Okay, what do we have here? So now we're in agents, agent.py, and right, so a lot of interesting things are happening here. We are constructing a mapping of tool name to tool for easy lookup. Okay, so that's where the text colors come from. Cool, there are some intermediate steps. Okay, let's keep going through this. Let's keep going through this. So I'm just using and to keep moving. Name to tool map. I wonder what lives here. Okay, so this is just a dict that maps the tool name to the tool itself. Okay, can be useful to know. Right, and there's a color mapping, so probably nothing too interesting. This is somehow used to output colorful text and make the output more readable. Intermediate steps. That seems like it might be of interest. But wait a second. This is not getting assigned. We are... Okay, let's... right, this is just the type here, and this is what it gets assigned to. So this will be an empty list. Okie dokie, iterations. So we started iteration 0, makes sense. Now this should continue. Okay, so this is some mechanism that checks whether we should continue based on the number of iterations. I wonder, whoops. So that's some method over here. Right. I guess we could run it on. What does it do with 0? Okay, with 0 it gives me a true, and I cheated a little bit because I read the body of this method when I was playing around with this before. So if I do 20 here, it should output false. Yep, because it won't run for more than 15 iterations. Cool. Let's keep going. Let's keep going. We are now inside that while loop. Oh, wait a second. Take the next step. That's actually interesting. That sounds like there might be a lot happening there. Let's step into that one. Again, we're looking at what's going on here. All right. So we are, where are we? We are right here. Let's keep stepping through the body of this function. And look at this. So this is some output that we get from the agent, and it says here, call the large language model to see what to do. Okay, that sounds interesting. And what are intermediate steps at this point? Okay, so there's nothing here still. And inputs, what are inputs? Inputs is just our dictionary that gets passed here. Okay, so let's step into that one. Okay. So, okay, so this seems like that's where the magic might be happening. So get full inputs. I wonder what that is. Let's see what we'll get assigned here. Inputs. So this is the input that will be passed to the machinery that will call out to the language model. Okay, so there's our input. There's the agent scratchpad that currently is set to just an empty string, and there's some stop condition. All right, so let's keep going. And so we're at this line right now, and get next action that does sound significant. So let's step into that method over here. And what do we have here? Okay, a bunch of other code, right. Oh, look at this. So our language, large language model chain is asked to predict on our full inputs. And full inputs are just these 3 values that are packed in a dict. All right, I suppose we have to step into that one as well. Let's see. Oh, look at this. So something has already happened here. Oh, this is just an example. Right. So another opportunity to step into the method. So this is just the dundercall method on where we are right now. On the large language model object. Well, let's step into that one. So I'm exploring the code, and I'm learning as I go along. And it might seem very chaotic to you, but if I were doing this for the first time, or if I were doing this just on my own, I would probably go much slower. I would probably maybe even take notes. I might jump into the code of the library a little bit more often, and that way I would build up my understanding as I go along. So let's see what happens here. Right, so there will be another opportunity to prep inputs. Wait a second, we already were here. Interesting. So nothing happened here as far as I can tell. Right, let's just keep going. Let's just keep going. Okay, so that was prep inputs, but on the large language model chain. Okie dokie, let's see what happens here. And maybe it's this method that will contain something more interesting. Oh, so maybe the magic happens in the apply method right here. Right, let's step into that one. Beautiful. Utilize the large language model generate method for speed gains. So this is where we will be actually making the call to the large language model, I hope. So let's see input list. So our list got put, our dictionary got put into a list. So I assume that maybe we can call out to the large language model with a batch of data. Who knows? But let's take a look at the generate method. Okay. Right. Prepare or prep prompts from input list. Ha, this sounds like something that might be of interest. Let's take a look. So what do we have here in prompts? Beautiful, you see. So our input string, our original prompt, got put into this prompt template. Let's see what it looks like. Prompts 0 text, and we can actually print it out so that it looks nicer. We can print it out so that it looks nicer. Okie dokie. Sorry, what am I doing here? We want to print it out. Print it out so that it looks nicer. Okay, so this is the prompt that will be getting sent over to the large language model. In our case, to the OpenAPI ChatGPT endpoint, GPT 3.5 Turbo. Okay, so you see, this is how it works. The prompt, it tells the model what we expect that it would do. So answer the following questions as best as you can, and it tells the language model that it will have access to the following tools. Google search. Okay, it tells what the tool can do, and it also tells the model how to use the tool. So, all right, question, the input question you must answer, yes. Then thought. Okay, but how does the thought get populated? How does it all work? Let's take a look. Okay, so for now, this is what the prompt looks like, and we're sending this over to the endpoint, to the API endpoint. Begin. There's the question. There's the thought, and the thought is empty. So we will use the completion functionality of the large language model and ask it to complete the thought for us, and possibly complete the to give us a completion up to some reasonable stopping point. So let's see what that looks like. Where we are in code, okay, generate prompt, right. So this is maybe in the interest of, but no, we probably have to step into this one, this function as well. Right. Okay, no, so this is not doing anything that we would not expect. Okay, look at this, what happened here. Output, what is output now? You see, output is a response from the API endpoint. And what did we get here? So output, and I think we can now just go generations. Can we do this? Yep, we can do this. Generations 0. Let's see, 0, and I think we need to go like this again. Right, and now we can take a look at the text that we got back. Print text. Okay, beautiful. So listen, we sent our prompt as we looked at it before to the large language model, and this is what we got in return. We got this bit of text. So that's outstanding, because it shows us that, well, it shows us exactly what the language model sends back to us, and also it tells us something very interesting about these large language models, and specifically ChatGPT 3.0. So it tells us that they are very good at following instructions, even if instructions seem quite complex and presented in this very template-like form, right? So you remember the prompt that we saw before. It outlined the steps, and somehow the language model was able to complete it in a reasonable fashion, and it also stopped at just the right point. So it didn't output the observation, for example. It understood that the observation is something else. Okay, let's keep going here. We can keep going. Right, wonderful. Okay. So you see, this is how I would step through a new library, and in the process, you know, having played around with the code, having looked at the objects, I now feel much better equipped to continue reading the code, to continue experimenting. Thank you so much for watching. I hope you enjoyed the video. Somewhere over here you can see my recent upload. Maybe that can be of interest to you as well. Let me know what you think. Let me know what you're interested in me covering, what I could do better. Would appreciate any feedback. Thank you so much. See you around.